Scatter plot and correlation coefficient. Suppose we want to examine the relationship between body weight and backpack weight, both quantitative variables in pounds. For example, for the first individual, their body weight is 120 pounds and they carry a backpack that weighs 26 pounds. For the second individual, their body weight is 187 pounds and they carry a backpack weight 30 pounds. So the backpack weight corresponds to the body weight. We have a scatter plot that displays the data, or in this case, the two quantitative variables. There are 1, 2, 3, 4, 5, 6, 7, 8. 8 dots represent 8 order pairs. In this case, we put the body weight in the horizontal axis and the backpack weight in the vertical axis. The body weight is therefore, in this case, the explanatory variable, and the backpack weight is the response variable. When we describe a scatter plot, we need to mention the form. In this case, it looks almost or approximately linear. We can fit a line that come close to most of these points, so the form is linear. The direction, in this case, we would need to draw the line upward. From left to right, the line is going upward. And so this is a positive association. It is not quite strong because some of the points are further away from the line that we would draw. And so we would use the term moderately strong. And since it is upward, it has the positive association. Since the relationship is positive, increasing in one variable also increases in another variable. What this means is that heavier hiker would carry heavier backpack. Similarly, lighter hikers would carry lighter backpack. We also need to check for any deviation from the pattern. It looks like there is one point that might not belong to the rest of the group. The individual with a body weight of 187 pounds that carry a 30-pound backpack. From the scatter plot, we can only estimate the strength of the relationship between two quantitative variables. If the relationship is linear, we can compute a number called correlation coefficient R that would determine the strength of the linear relationship. Only for linear relationship that we compute R. To compute R in this class, we would need to use a computer calculator, but in this case, we will use Desmos.com. Any calculator should be able to compute R. With Desmos.com, first, we need to input the values in the table by click the plus sign and then table. X1 represent the body weight and Y1 represent the backpack weight. For the first individual, the body weight is 120, who carry a backpack that weighs 26 pounds. For the second individual, 187 pounds, with the backpack weight 30 pounds. Next, 109 carry a corresponding backpack weight 26. 103, 24, 131, 29, 165, 35, 158, 31, and 116, 28. Once we double check the order pair that we enter in Desmos.com, to compute the correlation coefficient, we simply type C-O-R-R, open the parentheses. The data would enter in X sub 1, Y sub 1, so we have to type X and then underscores 1 for x sub 1. Exit out the subscript, comma. Do not put the comma in the subscript. Exit out of the subscript mode before typing the comma, and then y sub 1. It has to be x sub 1, y sub 1, because again, we enter the data in the table that label x sub 1, y sub 1. We computed that this correlation coefficient is 0.79. If we round it to 1 decimal places, this is 0.8. And it is a positive association. We saw it earlier, the graph is moving upward as we move from the left to the right. R is a number between -1 and 1, including -1 and 1. R is called the correlation coefficient. Any positive R would indicate a positive association. So in this case, this relationship is positive because the line would move upward. We will see that the correlation coefficient for this relationship will have to be positive. Then for negative R, the relationship would have to be negative, downward. Any value of R that is close to 0 or 0.1 or negative 0.1 and so on, around 0 indicates a very weak linear relationship. Any R values that is close to positive 1 or negative 1 would indicate a very strong linear relationship. Both negative 1 and 1 would indicate a perfect linear relationship. 1 would indicate a positive association upward when R equals 1, and when R equals -1 would indicate a negative association. We only end up with perfect 1 and -1 when all the points are on the same line. Keep in mind that both of the relationship that we just drew here, each of these relationships has only 2 points. If we only have 2 points, we would draw a perfect line that goes through the 2 points. That is why the correlation coefficient R is 1, positive association, and if it's downward, then it is -1. If there is another point that is not on the line, then we no longer have R equals 1. If the point is close to the line, then perhaps R is almost 1, or in this case, -1. And so the strength of the linear relationship increases as R moves away from 0 to 1. So moving closer to 1 or -1, this indicates a very strong linear relationship. It is a little bit confusing here because closer to 1 or closer to -1 both indicate a very strong association. It's just that one is positive and one is a negative association. Correlation makes no distinction between the explanatory and the response variable. What this means is that if we were to put the backpack weight in the horizontal axis and the body weight in the vertical axis, we would end up with the same correlation coefficient. R has no units and does not change when we change the units of measurements of x, y, or both. In this case, we measure the body weight in pounds, but if we were to measure the body weight in kilogram, the correlation coefficient remains the same. Positive R indicates positive association, and negative R indicates the negative association. And R is always a number between -1 and 1 inclusive. And most importantly, the correlation coefficient R is used for linear association only. Examine these 6 scatter plots. We see that the first scatter plot doesn't look like it can be a linear relationship. That is why the correlation coefficient is 0, very weak or no linear relationship at all. For the second scatter plot, the linear relationship is very weak, and if we were to draw the line that come close to most of this point, we forced to draw a line that is downward. That is why the correlation coefficient is negative, and it is very weak, so this number is negative, but it's almost or close to zero. For the next scatter plot, the linear relationship would have to be upward. In this case, not all the points are close to the line, upward line. And so the correlation coefficient is about 0.5. It is still weak because the points are not close to the line. Next, if we were to draw the line that comes close to most of this point, we would have to draw the line downward. This time, the points are not too far away from the line, but they're still far. And so that is why the correlation coefficient is about negative 0.7. It is negative because the line would be drawn downward. For the next one, we would have to draw the line upward, so the correlation coefficient is positive. This time, the lines come close to most of the points, and this is why the correlation coefficient is closer to 1, very strong. And the last one is very, very strong. If we were to draw the line that come close to most of the points for the last one, then the points are wrapping around the line. This is why the correlation coefficient is almost negative 1. It is very strong. It is not 1 because the correlation coefficient is 1 or negative 1 only if all the points are on the same line. The correlation coefficient requires that both variables be quantitative. So this is the Q to Q case when we end up with the scatter plot. The correlation coefficient cannot be used for non-linear association. So for example, for the first scatter plot, we say that the correlation is 0 because there is no linear relationship. If we were to take a look at this scatter plot, this is not a linear relationship. However, it is wrong to say that R is 0 in this case because R can only be used to describe or measure a linear relationship. This is not linear, so we would not use R in this case. R by itself is not good enough. We would need to supplement R with a scatter plot. And so we have the graphical displays for the Q to Q case and a numerical summary. In this case, the correlation coefficient R.